Hello everyone, my name is Almithra Carvosa and my project today for presentation is development of a food nitrate and nitrite database through quantitative instrumental. My aim is to develop a comprehensive and reliable database of nitrate and nitrite concentration in commonly consumed food using validated quantitative instrumental analytical methods. Nitrate and nitrite are naturally occurring nitrogen compounds found in a wide range of foods, particularly vegetables, processed meats, and drinking water. While they contribute to food quality and preservation, excessive dietary intake has been associated with potential health risks, making accurate exposure assessment essential. And this study aim is representative food samples were collected across major food groups and prepared using standardized laboratory procedures. The resulting concentrated value were organized into a structured database designed to support risk assessment, dietary intake studies, and food regulatory decision making. Introductions. Nitrate and nitrite are naturally occurring compounds found in vegetables, processed meats, and other foods. While they play important roles in food preservation and human physiology, excessive intake can contribute to the formation of harmful N-nitroso compounds. Accurate data on their levels in commonly consumed foods are limited, outdated, or inconsistent, making difficult assessment dietary exposure and potential health risks. This study develops a reliable database of nitrate and nitrite concentrations using qualitative instrumental analysis to support food safety, research, and public health and decision making. These are my materials I use in my lab workout and methods. These are my methods of my 6 samples, and all the reagents were prepared prior to analysis. We have to blend all the food samples in reagent 1 we prepared dissolving 11 grams of zinc acetate dihydride and 1.50 ml of prussic acids in 50 ml of volumetric flasks, while in reagent 2 was prepared by dissolving 530 grams of potassium hexocyanoferrate trihydrides in water to final volume of 50 ml. So the current reagent was prepared in a 250 ml volumetric flask by adding 150 ml of water, and we stir for 30 minutes and diluting in ammonium and diluting to volume. It was stored in a dark amber bottle and discussion was turned pink. The ammonium chloride buffer was prepared by dissolved 6 grams of ammonium chloride and adjustment the pH to 8.5 with 10% of sodium hydroxide. For sample analysis, 5 grams of sample were mixed with 40 ml of boiling water, followed by a small amount of activated charcoal, then centrifuged and filtered. Again, in beaker 1, 0.1 ml each of the color reagent and buffer were added, and mixture was kept in the dark for 30 minutes. In beaker 2, some small amount of zinc powder was added, and we use a filter paper to filter the food particles separated with liquid solutions. And small amount of zinc powder was added, and the mixture was stirred. The mixture was stirred, and it was left for 5 minutes. Then filter, after which 0.5 ml each of the color reagents, and buffer were added, and the mixture was again placed in the dark for 30 minutes. Then we prepare the next sample till we finish all the sample 6. These are my results and discussions, yeah, digestions, and all the measures that I take from sample 1 till sample 6. And the extractions, we use wavelength 550 nm, and we have 2 sets of absorbents before we add zinc powder and after we add zinc powder. So the sample masses are all around 5 grams, which shows that the variation in sample mass is minimal and unlikely to significantly affect the result. The blank absorbance is 0, 0, 0, so any measured absorbance is due to the analytes in the sample. So there is a considerable variations in absorbance among samples 0.101 to 0.871. Some samples, example sample 3, show very low absorbance, while other sample 4 and 5 are quite high. So now, after adding zinc powder, the absorbance increases for all samples after zinc treatment. Some sample, example sample 4, shows a large increase, while others increase moderately. Variability among samples decreases slightly in some cases, but overall differences remain. And the role for zinc powder is act as a reducing agent. Types of colorimeter other. Zinc is often added to reduce interference compounds or to convert certain nitrogen compound into a form that reacts with a color reagent. Its increase in absorbance after zinc addition suggests that some of the analytes was not fully detected before reduction, and after reduction, more of the analytes was converted to the detectable form, giving high absorbance reading. And some samples with very low absorbance initially, example sample 3, may have contained analytes in forms that do not react directly with the color reagents. And we have calculations. So sample 3 has the largest increases of 623%, suggesting most of its analyte was initially in an untreated or undetectable form. Sample 5 shows almost no increases, meaning most analytes was already in a detectable form. The increases in other sample was very depending on the fractions of analytes that required reductions by zinc. If we take the observance after zinc as the most accurate measurement of total analytes contents, the relative concentration can be expressed proportionally. In sample 4 has the highest analyte contents, followed by sample 1 and 2. Sample 3 and 6 have the lowest, but sample 3 would have been greatly underestimated without zinc reductions. In discussions, the observance that shows considerable variance among the sample before the addition of zinc powder. Some samples, such as sample 3, exhibit very low absorbance, while others, such as sample 4, 0.865, and sample 5, 0.871, show high absorbance. This suggests that a significant portion of the analytes in certain sample was initially in a form that was not reactive with a color reagent. After the addition of zinc powder, all samples show increased absorbance. Zinc, acting as a reducing reagent, converted the detectable forms of the analytes into detectable forms that reacted with the color reagent. The relative increases were particularly notable for sample 3, We have 6 to 3%, which has the lowest initial absorbance, indicating that most of its analytes was in reducible form. Other samples also saw varying degree of increase, reflecting differences in the chemical compositions and the presence of reducible species among the sample. The results demonstrated the pre-zinc absorbance underestimate the total analyte concentration. Samples like sample 5, which shows minimal increases, indicating that most of the analyte was already present in the detected form, while samples with a large increase contain analytes in forms that require reduction. Overall, the addition of zinc improved the reliability of the measurement by capturing the total anal content in all samples. And my conclusions that the additions of zinc powder significantly increased the meso absorbance of all samples, confirming its role as a reducing agent in converting adaptable annelid species into detected forms. The initial variation in the absorbance reflect difference in the chemical form of the analyte across samples. Samples with low initial absorbance experienced the largest increase after zinc treatment, highlighting the importance of the reduction step of accurate quantifications. And the two methods, the methods is more accurate and reliable when zinc is added. It ensures measurements of the total anode content rather than only the portions already relative with the color reagent. That's all I want to present. Thank you.